let us look at law 3 of exponents. So in this we look at a to the power of n into the power of n equals a to the power of n times m. A is not equal to 0, but m and n are integers. We know that integers can be numbers that are negatives or positives. Also, 0 is an integer. So now let's look at example number 1. We see how we can apply this law into it. So in number 1, let's have 7 to the power of 3 into the power of 2. Now in this scenario, we will get 7 to the power of 3 times 2. So this will give us 7 to the power of 6. Okay, let's continue with another example. In number 2, let us have b to the power of 4 into the power of 5. So we will get b to the power of 4 times 5. So we come up with b to the power of 20. Okay, so let's move on to example number 3. In number 3, let us have 3 to the power of x into the power of 4 times 3 to the power of 2. You can also call it 3 squared into the power of x. So we will come up with 3 to the power of x times 4 times 3 squared times x, so that we get 3 to the power of 4x times 3 to the power of 2x. Now, since the bases are the same, we can add their powers so that we come up with 3 to the power of 4x plus 2x, such that we come up with 3 to the power of 6x, and that becomes our final answer. Let's move on. We try another example. Example number 4. A cubed, or you can say a to the power of 3 into the power of b times a to the power of b into the power of 7. Now in this, we will come up with a to the power of 3 times b times a to the power of b times 7, so that we get a to the power of 3b times a to the power of 7b. And since the bases are the same, we can simply add the powers. So we will get a to the power of 3b plus 7b, and this will give us a to the power of 10b. So this becomes our final answer. So law of exponents states that if a is not equal to 0, b is not equal to 0, n is an integer, then a to the power of n times b to the power of n equals a times b into the power of n. But this is also the same as a times b into the power of n, the same as a to the power of n times b to the power of n. So let's move on. We see how this can be changed into law 5 of exponents. In this also, a is not equal to 0, b is not equal to 0, whereas m, n, and k are integers. So let's apply these two laws in these following examples. So number 1, let us have 3 to the power of 5 times 7 to the power of 5. So this means that we'll come up with 3 times 7 into the power of 5. And of course, this is the same as 21 to the power of 5. And let's move on to number 2. So in part number 2, if we have 2 to the power of 4 times 5 to the power of 4, you can see that this is actually the same as part 1. So we will have 2 times 5 into the power of 4, and this will give us 10 to the power of 4. Okay, let's move on. We get example number 3. In part 3, let's have 2 to the power of 3 times y squared into the power of 5. So in this, we'll have 2 to the power of 3 times 5 times y to the power of 2 times 5. So we get 2 to the power of 15 times y to the power of 10. So this becomes our final answer. Let us move on with example number 4. And we get 2x squared y cubed into the power of 4 times x y cubed into the power of 2. Okay, so we have got to be very careful as we go slowly and step by step. So we will get 2 to the power of 4. Then we have x squared times 4. Then we have y cubed times 4. That is our first part. Then the second part, we have x squared, then y cubed times 2. So the next step, we get 2 to the power of 4, that is 16. Then we have x to the power of 2 times 4 is 8. Y to the power of 3 times 4, that is 12, times x squared and y to the power of 3 times 2, which is 6. Okay, now we get 16 x to the power of 8. Now we can bring this x, that is x squared, then we bring this y, that is y to the power of 12, and this y, which is y to the power of 6. So we get 16 to the power, we get 16x to the power of 8 plus 2, then y to the power of 12 plus 6. So we come up with 16x to the power of 10, y to the power of 18. And this becomes our final answer.